All right. Well, how's everybody today? Great. Love to hear it. So, a couple of quick announcements before we get going. We took our second exam last Friday, so anybody interested in retaking that, you have until this Friday morning at 8:05. In fact, this Friday is going to be the end of the 9 weeks. Ooh, Noah. All right, you just have to have the sinusoidal applications assignment turned in prior to that. Now, part of what I want to do today, oh no, he must. Part of what I would like to do today, we will go ahead and start looking at the homework, even though it's officially due tomorrow, but we have our quiz on inverse trig functions Thursday. So we want to be looking ahead to that. In fact, because it's the end of the 9 weeks, I'm going to carry that grade over. So we're going to start the second 9 weeks right out the bat with a grade. It's going to be a good grade, right? It's going to be the highest class average. I love the confidence. And don't forget, this coming Thursday morning by 8:05, that is the deadline if anybody's interested in the extra credit that I'm offering. I've had a lot of those turned in, so I still have some extra copies if you need one, but let me know and we'll go from there. Okay, questions? Okay, well then let's go ahead. This is one of the sheets that you pulled out, or that you got yesterday, that hopefully you just went ahead and pulled out. So this contains all the domains and ranges for all of the inverse trig functions that we have. The top 3, we've been spending a lot of time on that. The bottom 3, this is what we started to look at yesterday. We've got the intervals for the ratios and where our answers are going to be, the quadrants where they're going to be restricted to, all that good stuff. Now, when we got into it yesterday, like, for example, secant inverse of x, what was our strategy? How did we solve something like that? We took the what? Started with an r. We take the reciprocal. You take the reciprocal of the trig function and the ratio. So secant inverse of x becomes cosine inverse of 1 over x. Cosecant inverse of x is sine inverse of 1 over x. The only one you don't, you do want to be careful of is cotangent inverse of a negative ratio. If it's negative, you'll still take the reciprocals and evaluate, but then you'll have to add pi to what you get. The reason being that cotangent inverse can only be in quadrants 1 and 2. Tangent inverse can be in quadrants 1 and 4. So if it's negative, you're in quadrant 4, that pi is going to put you back in the quadrant where you need to be. Okay, and what is this word arc? What does that word arc mean? It's the same thing as that inverse. It's -1. That's all it is. It's just another way of showing that inverse. Okay, so we went through several examples. Okay, everybody seemed to be doing just fine on that. And here we go. These are the last 2 problems for this lesson. So this is a super short lesson, which is why we're going to take some time today to talk about the assignment. Okay, so example 5, it says find the exact value of cosecant of cotangent inverse of 1/2. So with the composition, remember you're working 2 functions back to back. The answer for the first function will plug directly into the second function. So for this one, we're going to ignore this cosecant. Okay, I want to evaluate cotangent inverse of 1/2. So cotangent inverse of 1/2. So I'm going to start by rewriting it how? What's the reciprocal of cotangent? Okay, so I'm going to say tangent inverse of what? 2. And you can leave it 2 over 1 because we're about to use that as lengths of the triangle, but I think that'll work out. Okay, remember we solved these new ones by taking the reciprocal, but I've already seen a lot of people doing this today. If we come across sine inverse, cosine inverse, they're wanting to take the reciprocal of those. We only take the reciprocal if it's cosecant inverse, secant inverse, or cotangent inverse. Okay, so what quadrant is this in? 1 or 4? 1, because it's positive. Okay, so I'm going to go ahead and draw this triangle right here. So this angle theta, this is what I'm trying to find right now. Tangent is 2 over 1, that's y over x. Remember, being a ratio, this gives me side lengths of the triangle. So I know this height is 2, I know the base is 1. What's the hypotenuse? Square root of, oh, not 3. 5. There we go. Square root of 5. Okay. Anybody want me to run through Pythagorean? Okay. Now here's the big question. Special right triangle, yes or no? It is not. So this is one of those many times we've seen, even though I have no idea what this angle theta is right now, let's just go ahead and say, okay, that's my answer. But I'm still going to go ahead and take that value, and I'm going to go ahead and insert it into the next trig function. Yeah.
62 degrees because we know that from the last problem.
63. That is true, but we're kind of working off the idea that we wouldn't know that. So we don't have technology and we don't have the ruler and the protractor to help us out. But I mean, even if we were to do that, plug in the 63, we're still going to have the what triangle? The same triangle. We're still going to say they're identical. Okay? Because in this case right here, now I want cosecant of that angle theta. Well, I can tell from my first picture, it's got to be positive and it's got to be acute. That's a C right there. So let me go ahead and draw a positive acute angle. And we want to be careful here. I'm still seeing folks confusing the inverse trig function rules with the normal trig function rules. See, this isn't an inverse, this is just cosecant, so I'm going to use this angle to create a right triangle. I don't know that angle, so in this case, I'm going to reproduce what I have here. Okay. So what is cosecant's ratio? Let's see, it was R over Y. So in this case here, that's the radius. Square root of 5 over 2. There we go. And Harrison, this goes back to what you were just saying. If we had just taken it at 63 degrees, see, I still would have ended up with the identical triangle and still got the same answer. Gotcha. Okay. So it's the same type of problem. I mean, we incorporated an inverse trig function that we had to take the reciprocal of. But other than that, were there any questions? Anybody not sure how I got something? Okay. Well, let's try one on our own. Try number 6. Let me go ahead and get out the timer here. Okay, so 2 minutes. We're trying to evaluate secant of cosecant inverse of -2. Secant of cosecant inverse of -2. So only a few people have got this right today, so I'm expecting a whole lot of hands to get. Excuse me. Yes. Oh, do you want me to check your answer? Yeah. Close. Remember, the inverse is so that is how you would start the problem. 1 minute. One seconds. Okay. So here is what you should be getting. 2 square root of 3 over 3. Okay, how many people got that? Okay, so it's not bad. Okay, a few hands going up. Okay. What you'll find here is that this one actually turns out to be a special right triangle. So that was actually pretty nice to us. So let's start with the first part right here. Let's see how we got that answer. So we have cosecant inverse of a -2. How am I going to rewrite that? So now it's going to become sine inverse of what? Sine inverse of a -1/2. Perfect. Okay. So what quadrant? 1 or 4? 4, because it's a -1/2. All right, so I'm going to draw this right here. Okay. Sine is always y over r. So I know this hypotenuse is 2. I know this height is a -1. What's the leg? Square root of 3. Again, anybody want me to run through that? Okay, so this one is special. It's a 30, 60, 90. So what's this angle here? Okay, that is 30. Okay, remember, the smallest angle has to be across from the shortest side. Okay, so I'm gonna go ahead and rewrite this as a radian measure. So that would be a -pi/6. Because pi/6 is 30 degrees, but why is it negative? Because what? It's in quadrant 4. Remember, you always rotate from standard position to the hypotenuse of the triangle. So I had to rotate clockwise, so that's why it's negative. So how many people got that far? Okay, good. More hands going up. Okay. So now I'm going to take this -pi/6, and I'm going to go ahead and plug it into the other trig function. And remember, that's the nice thing about these problems. Even if I hadn't ended up with a special right triangle, and I'd had some unknown ratio with variables, I still would have done the exact same thing. Okay, so now I'm looking for secant of that -pi/6. Okay. Well, it's negative, so I'm going to go clockwise. Pi/6 would be in quadrant 4. So let's say this is pi/6 right here. Now remember, this isn't an inverse. This is your normal secant. Okay. So we're choosing the quadrant based on the angle. So I'm going to use this angle, create a right triangle. Okay. Now, this is also something that's come up in other classes. Could I just recreate the other triangle? Could I use the side lengths of 2, -1, and square root of 3? I absolutely could, because remember, they're what? They're similar. But I think this is the perfect opportunity. Let's review how to do this on the unit circle. Does anybody remember what was across from the pi/6? The 30 degrees. What fraction? 1/2. So in this case, it would be a negative just because of the quadrant. What was across from 60? Square root of 3/2. Now, go ahead and compare the two triangles here. This first triangle, if I multiply each of these lengths by 2, see, I'm going to get the other triangle. Again, there's the similarity that we keep talking about. Okay. Well, somebody help me out. We're almost done with this. What's secant's ratio? Okay, it was r over x. Okay. So in this case, the radius is 1. Okay, x is square root of 3/2. So we're going to multiply by the reciprocal. So this is going to give me 2 over the square root of 3. But I have to what? This time we do want to rationalize. So that's where I got the 2√3/3. Now, even though we came up with a specific triangle that we knew what the side lengths were, remember, even if you had just duplicated it and used 2, -1, 3, you're still going to get the exact same answer. All right. Any questions about that? Okay. So we've been working on compositions for a while now. How are we feeling? Okay. Is there anything I can do to help out? Okay. Well, at this point, we're done with this next lesson. That's one of our short lessons for the year. Okay, so let's go ahead and put that to the side. Go ahead and pull out the assignments that was due tomorrow over the regular inverse trig functions. Okay. All right. So we'll go ahead and start to look at this today. Probably even have some time in class to go ahead and work on it yourself. But there are a few problems that I think might be beneficial to go ahead and work with you. And we probably will even get somebody up here to the board to help us out. Okay. So the first section, these are not compositions. They are just normal inverse trig functions. Okay. Would we like to go ahead and work one of those? Oliver, which one would you like? Yeah. I passed that out on Friday. Is that right? You weren't here Friday? Okay. I think I got some extra copies here. Okay. All right, so pass that down to Noble. All right, sorry about that. Yep. There we go. Good morning. Yeah. Go. All right. Okay, so Oliver, which one would you like? Number 4? Okay. So number 4 says sine inverse of a root 2 over 2. Okay. Oh, did I pass out something different? I passed out the notes. Oh, okay. Silly me. Okay. Let's see. What did I do with that? Okay. Here we go. Here we go. Looking in the wrong pile. There we go. Let's try this. Okay, there we go. Let's try that. Does that look better? Okay, here we go. So number 4, because it's sine inverse of a positive, Mason, 1 or 4? 1. Okay, so I'm going to go ahead and draw a triangle right here. Okay, so this is the angle theta that I want. Okay, sine is y over r. So I know this hypotenuse would be 2. I know the height is going to be a root 2. Okay. Vanessa, what's that other leg? It is root 2, yes. Okay, so looking at this triangle right here, Kagan, what kind of special right triangle is it? 45-45 or 30-60? Yes, 45-45. Now remember, for these problems, if it turns out to be a special right triangle, and our final answer is an angle, we want to write that as a radian. So 45 degrees would be pi over 4. There we go. Yes, sir. Uh-huh. Oh, no, because on the quiz, you won't have a calculator. But that's okay. That's, I mean, while you're working right now, I mean, you could use it to confirm and see that you're on the right track. I mean, that's okay. Okay. But unfortunately, yeah, no calculator for the quiz. Okay. Well, let's look at the next section. So this one here, it says specifically use a calculator to go ahead and find each expression. Now, if you didn't have a calculator, there is another way you could solve these problems. You could use a ruler and protractor. Now, I'll go ahead and tell you straight up, the quiz, test, all that coming up, I will not have you measure by hand. I've actually removed those from the assessments. But did anybody want me to go ahead and run through one more of those? Okay. Well, then, let's look at section 3. And I'm hoping, how many people have had the opportunity to look at the assignment? You folks? Okay. Well, there are a couple of problems on here that we've already worked together. You remember the first 2 compositions we did at the beginning of class yesterday? That was numbers 14 and 18. So we've already gotten those worked as well. Okay. So why don't we start with, say, number 17. Cosine inverse of a cosine of a negative 3/7 pi. All right, we're wanting to find the exact value of each expression. Okay. Now, let's go ahead. I'm going to give you 2 minutes to look at this one, and then I'll spin the wheel of destiny, and we'll get somebody up here to help me out. We are on number 17. Now, I will go ahead and tell you, if you're working a composition where it not only has the trig function, but its exact inverse, this is the only time where the original value could potentially be the final answer. So the final answer might be negative 3 pi over 7. Well, we've also seen several examples where that's not always the case. So 2 minutes. Let's see what we got. I want to. My sister and I always went to the Spurs game. Are we going to bring it home? We are. Huh? I always say Lowry, but it's what's it called now? Plains Capital. Okay. I've called it. It's been Lowry ever since because I lived right by Lowry when I grew up. Yeah, so we always used to go there and play before they put the fences up. It was awesome. Mm-hmm. Okay. Your defense is okay. When was the last time we had the Spurs? So I think it's time for a change. Wow. What time's the game? 7 o'clock. Okay. Okay, give that a good shuffle. Okay, let's see. Who's going to help me out? Caleb. All right. And don't worry, sir. We're going to help you out. It's okay. Okay. So the first thing we want to take care of is cosine of negative 3 pi over 7. Okay. So this is a normal trig function. Where is negative 3/7 pi? What quadrant? What's that? It is in quadrant 4. Okay. So let's draw an angle in quadrant 4. And go ahead and click that marker button again just to be on the safe side. It's right below the mouse next to A. Right here. There we go. Yeah, there we go. Yeah, so start at the origin and then just go ahead and draw that in. Perfect. Okay. So let's say that is 3/7 pi. Okay. So let's use that to create a right triangle. Okay. Now, what do we think? Special or no? It's definitely not special, but we still have a triangle, right? Okay. So, Caleb, what variable am I going to use here for the horizontal length? What value goes left and right in my grid? X, okay. All right. So what can I call this here? If the horizontal is X, then the vertical would be Y. Okay. And then our hypotenuse is R. And remember, this right here, you already drew the angle. This is 3 pi over 7. Okay. So for cosine of negative 3 pi over 7, okay, well, what's cosine's ratio? What two variables make it up? Okay, we're going to take a fraction. So remember, cosine is what variable? Was it x or y? X. Okay. And I'm going to put that x over what? Which other one? Is it going to be y or r? R. There we go. So see, without this being a 30, 45, or 60, I don't immediately know what these lengths are. So that's why I had to put x, y, and r. So we'll say that cosine of this angle is x over r. So now I'm going to take this angle, whoop, now I'm going to plug it right in here. So now I want, this is going to look awful because I'm doing this with a mouse, cosine inverse of x over r. Okay. Now, Caleb, help me out. What would this fraction be? Would it be positive or negative? Be positive. There we go. Because remember, our radius is always positive, and since we're in quadrant 4, x will be positive as well. Okay. Now, cosine inverse can only be in 1 or 2. Knowing this is a positive, which one would I go into? Okay. So we're going to draw a triangle here. Again, that looks awful. I'm doing it with the mouse. I do apologize. Okay. So, Caleb, what do I know about these two triangles right here? They have to be the what? Same or different? They got to be the same. Okay. So tell me, what would this horizontal length be here? What was the horizontal length in the other triangle? X. Okay, so let's write that X. Okay, what would the height be? Y. Perfect. Okay. And what about the hypotenuse? R. Okay. Is there anything else about this triangle that I would know? So what's the angle opposite the y side? 3 pi over 7. So here's my y height. So what would be right here? Remember, if these two triangles are the same, and 3 pi over 7 is across from y, then what would go right here? 3 pi over 7. Let's go ahead and write that down. Okay. 3 pi over 7. So knowing that I have to rotate from standard position to this hypotenuse, okay, Caleb, what is my final answer? What was it that you just wrote? That's it. So go ahead and put 3 pi over 7 right there for me. Perfect. Okay, good job. Okay, thank you. Okay, questions. Everybody okay how we went through that? Okay. Fantastic. Good job. Good job. All right. Well, let's take a look at the next section. This one we'll probably do a couple out of. I like this section because it gives you a possible answer, and then you just have to tell me is it true or false. Okay. So let's go ahead and work one of these together. Which one would you like? No, they all look so good. 22. Let's do 22. Okay. So will tangent inverse of tangent of a negative pi over 3 give me negative pi over 3? All right. Well, let me go ahead and write down this problem here. So we're trying to simplify tangent inverse of tangent of a negative pi over 3. Okie dokie. Well, the first thing I'm going to do is start like we always do with the inside trig function. So tangent of a negative pi over 3. Now, this is the normal tangent. It's not an inverse. Okay. So what quadrant is that negative pi over 3 is it going to place me in? That would be in 4. Okay. So I'm going to draw an angle right here. Okay, so this is pi over 3. Now, what is pi over 3 as a degree? That's 60, so this one's going to turn out to be what? 30, 60, 90. This one's going to be special. Okay, so that's going to make it a little easier. So I'm going to use this angle to create a right triangle. Okay, so let's say my hypotenuse is 1. And we just saw this a few moments ago. Remember, across from 60, that was the square root of 3 over 2. What was across from 30? 1/2. Now, there's something I'm forgetting, though. There you go, because we're in quadrant 4, that root 3 over 2 would be negative. That's our y value. Okay. Well, tangent is always going to be y over x. So in this case, the y value is at negative root 3 over 2 divided by the x 1/2. Is everybody okay how I'm setting that up? Okay. Well, I'm dividing by a fraction, so what does that mean? Multiply by? Okay, good. By 2 the reciprocal. So this is going to be negative root 3 over 2 times 2 over 1. When the 2's cancel, it looks like tangent of a negative pi over 3 equals what? Negative root 3. Okay. Buddy, okay with that? How do I keep going? What do I do now? Okay. Let's take this answer. I'm going to plug it right into the next function. So tangent inverse of this negative root 3, bless you. Okay. All right. Well, it's tangent inverse of a negative. Okay, so let's see, who haven't I talked to today? Alex. 1 or 4? Tangent inverse of a negative. Would that be 1 or 4? 4. So I'm going to draw a triangle right here. Boom, boom, boom. Okay. Now remember, I'm using the ratio that we have here. So this is now my y. This is the x. So this is a negative root 3. This would be 1. What's the hypotenuse? 2. So we could have simply duplicated the triangle. But remember, similarity is still happening. If I take all of these originals, multiply by 2, see, I'm going to get these lengths over here. Okay? And I know that because square root of 3 is bigger than 1, this has to be pi over 3, the 60 degrees. Okay? Now, it is in quadrant 4, and I have to rotate clockwise, so is my final answer a negative pi over 3? Yeah. So what do we see about 22? It is true. Now, the one thing about these problems here, it says, how does it word it? It says give a reason for your answer. Well, I think the reason, that's your work. That's your justification right there. Okay. All right. Great. Fantastic. How are we doing? Okay. So I will go ahead and let you folks decide now. We can do one of two things. Okay. So I can go ahead and give you the remainder of the time to go ahead and work on the assignment. If you have questions, you can come ask me. We can do that. Or we can just go ahead and keep working some problems together. Okay, so think about it for a second. We'll go ahead and vote. How many people want to continue working problems together? Okay, we got 1, 2. How many people want to take the rest of the time to just work on the assignment? Okay, and how many people are not going to vote? There we go. Okay, so majority wins. Okay, so remember that tomorrow we'll go ahead and look at this again. We are going to start the next lesson over in trigonometric identities, but we do have the quiz over this when? Thursday, so we're a couple of days out from that. All right. Well, folks, great job. I do appreciate it. Remember, now that we have a little bit of downtime in class and you're going to be working on an assignment or possibly something else, please remember, keep your phones up, earbuds. Now, if you have a wired set of earbuds and you want to plug that into your Chromebook, that is okay. That is okay. But everything else, we got to keep up. All right. So do your thing.